So today I will be looking at deriving formulas. This time we are now going to look at infinite dimensional space. We are now going to tackle the concept of infinite dimensional rectangles. Yes, infinite dimensional rectangles. Now you may be thinking, that's crazy. You can't multiply infinite numbers together. How are you supposed to do it? Well, that protesting person in the audience is surely right. But us, we are going to look at hyperoperators. Great. So our first hyperoperator that we know is a plus b addition. Now we have a times b, so we write it this way, and then we have a to the power of b, and you notice that multiplication is addition many times and exponentiation is multiplication many times. Now the natural next step will be tetration. Yes, it is exponentiation many times, and it's gonna be our basis for the next hyperoperator. Well, actually no, because after tetration you can have pentonation, pentation, hexation, which is just nesting all of these inside each other, which is quite interesting, you ask me, but a bit boring, because we can go down to the depths and look at a zero hyperoperator comparison. So it will return a when it's greater than b, and b when it's greater than a, and a or b if a is equal to b. So we only have these 5 operators in our portfolio right now, and we are now going to look at hyperrectangles. Yes, infinite dimensional rectangles. Now you're thinking, that's crazy, how could you? Okay, calm down and I'm gonna explain. Let us introduce 4 lands. In ray land, everything stems from a point. There is overlapping. In line land, it's just a line. Yes, it's just a line, and it's 2-directional, if you ask me. And in ray land, it has 2 thickness. So thickness, line length is direction. And in flat land, we have dimension. And our area of rectangle is of course a times b. And let's call this land new land, for lack of a better name. Let's just call it hyperdimension. Let's just call it hyperdimension. So it's so new land is a 2 hyperdimensional world, if I know what that means. And we are now going to use our hyperoperators to make hypersquares. Now what are hypersquares? It's just hyperrectangles, but slightly more particular in that all the things have to be the same length. All the sides have to be the same length. So now you may be thinking, how do you make infinite dimensional rectangles and squares with only just a few parameters? It's simple. In Rayland, so let's call it R. Let's call our Rayland R. The area of a hypersquare is A compare A. A compare A equals A. In Lineland, the area of a square is A plus A equals to A times 2. In Flatland, it is A times A equals to A squared. In Newland, guess, A to the power of A equals to A tetrated to 2. There, we solved our problem of hypersquares. Now, hyperrectangles. In Rayland, Lineland, Flatland, and Newland. In Rayland, it is A compare B. In Lineland, it is A plus B. In Flatland, it is A times B. And in Newland, it will be A to the power of B. Now let's not be too impulsive about this choice, because since the first three operators are commutative, we can might as well write them in this form. And continuing the progression out from this column, we will have b to the power of a. Wait, we had discovered a contradiction. U-land hyperrectangles cannot have hyperarea a to the power of b and b to the power of a at the very same time. So what do? We solve a problem. Yes, we solve a problem. We solve a very pertinent problem. So in line-land, flat-land, and U-land, we exclude ray-land because it's too simple to have any description. So in line-land, our hyperrectangles have a plus b compare b plus a. In flatland, we will have a times b plus b times a over 2. And of course, we can compare after the plus, so we can write it this way. And we just omitted it in line-land because it's a compare operation. Now in new-land, and this is getting tricky, so we can use the negation. This is our base, and this could be our root, and this operation could be multiplication. So the new land could be rectangle could be the square root of a to the power of b times b to the power of a. There, we got our expression for the area of a hyperrectangle. Sounds great. Besides that, I have nothing much to say, although I am still thinking about things about dimension. So line-land has one thickness and it adds 2 directions. Flatland has 4 directions, and new-land has an infinite number of directions. And to put it in a metaphoric statement, ray-land will be the set of all natural numbers, line-land will be the set of integers, flatland will be the set of linear functions, and new-land would be the set of all polynomials. Great. So ray-land, line-land, flatland, new-land go very close together if you treat them properly and give them hyperrectangles. So see you and have fun with this new system.